Muy buenas tardes. Invitamos a todos los asistentes a ocupar sus lugares para poder dar inicio con este evento. Igualmente invitamos a los integrantes del Presidium a ocupar sus lugares, por favor, aquí en la mesa. Les pedimos también cambiar sus teléfonos celulares a modo silencioso e igualmente les informamos que nuestra conferencia será en idioma inglés, por lo que invitamos a las personas que requieran de un aparato de traducción simultánea, lo soliciten a la entrada de este salón. Todo en italiano, solo cachitos. Voy a hacer mi máximo esfuerzo. Les pido de su atención para escuchar un mensaje de protección civil antes de iniciar. Siguiendo el protocolo de actuación en materia de protección civil para el auditorio Carlos Lazo del CAMSAM, en caso de presentarse alguna emergencia, les informamos que el auditorio cuenta con una salida de uso normal y 2 salidas de emergencia. Si ustedes se encuentran con vista frente al podio, me ubicarán al costado izquierdo una de las 2 salidas de emergencia. La otra se localiza en la parte superior del auditorio, subiendo las escaleras a su costado izquierdo. En caso de escuchar la alerta sísmica o se suscite alguna emergencia y se tenga que desalojar el sitio, se les pedirá que se dirijan a la salida más cercana y procedan a evacuar lo más rápido posible en orden y en silencio, acatando las instrucciones de los brigadistas y del personal del colegio, quienes señalarán las zonas de menor riesgo y la ruta más segura para la evacuación del edificio. Una vez iniciada la evacuación, se les pide, por favor, no tratar de regresar al sitio ni dispersarse del grupo. Diríjanse, por favor, al punto de reunión exterior que se ubica en el estacionamiento del CAMSAM y en este sitio se atenderán las instrucciones de los brigadistas y personal del colegio. Se podrá reingresar al inmueble una vez que se haya atendido la emergencia y se haya dictaminado que el área es segura. Muchísimas gracias por su atención. Pues muy buenas tardes, sean todos ustedes bienvenidos. El American Concrete Institute, sección Centro y Sur de México, les da la más cordial bienvenida a la conferencia Nuevas Iniciativas del American Concrete Institute y el nuevo Código para Concreto Reforzado con Barras Compuestas, donde al terminar llevaremos a cabo la toma de protesta simbólica de la 26ª mesa directiva del American Concrete Institute, sección Centro y Sur de México para el periodo 2023-2025. Antes de dar inicio, permítanme presentar a quienes nos acompañan esta tarde en el Presidium. Se encuentra con nosotros el ingeniero José Alfredo Rodríguez Campos, vicepresidente de la 25ª mesa directiva de la sección Centro y Sur de México del American Concrete Institute. Bienvenido. También nos acompaña el maestro en ingeniería Sergio Valdés Constantino, director de Finanzas y Administración. Bienvenido. Y por supuesto, nuestro orador de lujo, el doctor Antonio Nani, presidente del American Concrete Institute. Bienvenido. Benvenuti. Saludamos con el mismo agrado a invitados especiales que nos acompañan esta tarde, como son los expresidentes, el maestro en ingeniería Gustavo Montoña Aguilar, el maestro en ingeniería Marco José Farachi Capón, el maestro en ingeniería Homero Montaño Román, el maestro en ingeniería Arturo Gaitán Covarrubias, el maestro en ciencias Jorge Javier Martínez Chávez, E igualmente nos acompaña la arquitecta Dinora Franco Flores, secretaria general del Colegio de Arquitectos de la Ciudad de México y la Sociedad de Arquitectos Mexicanos. De igual manera, saludamos a miembros del American Concrete Institute, a colegas presidentes de colegios e institutos de ingeniería y arquitectura, a los capítulos estudiantiles que nos acompañan presencialmente y virtualmente y a todos los que nos acompañan esta tarde. Sean todos ustedes bienvenidos. Para dar inicio, escuchemos el mensaje del vicepresidente de la sección Centro y Sur de México del American Concrete Institute, el ingeniero José Alfredo Rodríguez Campos.
Bueno, buenas tardes a todos. Primero que nada, en nombre del arquitecto Arturo Rodríguez Jalil, presidente de la sección Centro y Sur, les doy la más cordial bienvenida y gracias a todos y todas por estar acá presente. Voy a ser, la verdad, muy breve. Solamente quiero agradecerle al maestro Antonio Nani por estar acá. Agradecer también a Arturo por todas las gestiones que hizo para la visita de Antonio Nani, no solo acá, sino en México. Está teniendo sesiones con las 4 secciones de ACI, lo cual creo que es histórico porque nunca se había logrado hacer eso. Muchísimas gracias por todo el apoyo. Básicamente lo que les quiero decir es que esta es su casa. Bienvenidos. Aprovechemos esta oportunidad. No siempre tenemos la visita de un presidente de ACI Internacional y personalmente le agradezco mucho el que esté acá con nosotros. Muchísimas gracias a todos.
Agradecemos muchísimo el mensaje del ingeniero José Alfredo Rodríguez Campos. Vamos a dar inicio con la conferencia titulada Nuevas iniciativas del American Concrete Institute y el nuevo código para concreto reforzado con barras compuestas. Les informamos que al finalizar la conferencia, si es que el tiempo lo permite, tendremos un espacio para preguntas y respuestas, por lo que les pedimos levantar la mano y nuestro personal de apoyo les acercará el micrófono. Antes de darle la palabra a nuestro orador y de invitar a los integrantes del Presidium a ocupar su lugar en la primera fila de este auditorio, quisiera compartir con ustedes un poco de la trayectoria de nuestro orador. Antonio Nani es académico senior y profesor y presidente del Departamento de Ingeniería Civil y Arquitectura de la Universidad de Miami. Sus temas de investigación son relacionados a materiales de la industria de la construcción, su desempeño estructural y aplicación en campo con un enfoque en la sustentabilidad y resiliencia de edificios e infraestructura civil. Es director del Centro de Investigación Cooperativa de la Universidad de Miami y de la Fundación Nacional de Ciencias para la Integración de Compuestos en la Infraestructura. Durante los últimos 35 años, Nani ha estudiado las características del concreto y los sistemas avanzados basados en compuestos. Esto lo ha llevado a cabo como investigador principal en muchos proyectos de investigación patrocinados por agencias federales y estatales, así como por la industria privada. Algunos de los proyectos de campo innovadores en los que contribuyó han recibido premios nacionales. Su investigación en materiales y estructuras ha impactado el trabajo de los comités técnicos de redacción de normas en los Estados Unidos y en el extranjero. Es editor en jefe de la American Society of Civil Engineers Journal of Materials in Civil Engineering y es miembro del consejo editorial de otras revistas técnicas. Desde que regresó a la Universidad de Miami en 2006, ha asesorado a 31 estudiantes de doctorado, ha publicado 158 artículos en revistas, también ha publicado 216 artículos en memorias de congresos y es coautor de 2 libros. Durante su carrera ha recibido muchos premios y reconocimientos, incluido el Caballero de la Orden de la Estrella de Italia, otorgado por el presidente italiano en 2019. Fue elegido presidente del American Concrete Institute y se desempeña como presidente número 100 en el periodo 2023-2024. Es miembro de 4 sociedades técnicas en Italia y 4 en Estados Unidos, entre otras. Así que, sin más preámbulo, dando inicio con la conferencia Nuevas iniciativas del American Concrete Institute y el nuevo código para concreto reforzado con barras compuestas, le pido por favor a los miembros del Presidium ocupar sus lugares en la primera fila y darle un fuerte aplauso a nuestro orador para que inicie con la conferencia. Mr. Nani, il microfono è tutto tuo.
Me gustaría hablar español, pero no puedo. Yo digo la misma cosa todas las veces. Puedo hablar un poquito de español después de una copa de tequila. Pero me dieron agua, no tequila, así que va a ser en inglés. I want to start with some remarks that are really off script. First of all, as was mentioned, I've been visiting 2 other chapters so far in Hermosillo and Monterrey. And this experience has been exceptional. And in particular, meeting the students has been an experience, in my mind, of a lifetime. And I would like to take this opportunity to thank the chapter for having provided help to the students to create a student chapter also here in Mexico City. The other thing that I want to mention off the script is in talking to the student and also some of the former president of the chapter, I mentioned to them that these are the most exciting times for our industry. No, in my 35 years, well, maybe 38 years that I've been in this business, I've never seen this excitement. And this excitement is because of the sustainability call. You know, we were mentioning that in the 40s, late 40s and 50s, PCA, the Portland Cement Association, was conducting incredible research. And that disappeared. Why? Because there was no reason for the cement industry to look at innovation. Today, that innovation is at the core of what they do. These are the best times. I'm telling the students, I envy you. I wish I could go back with the experience that I have now and be in your shoes. You are the future in a time that is the best ever. So with this, I think before I go there, I just want to make another remark off the script. And I'm not sure that this will please you, but I think I'm compelled to do it. Many people in the past few days and today want to take pictures with me. I'm delighted to do it, but I'm going to ask you the following. If you take a picture with me, and this is not my idea, is one of the former president, and the incoming president also is supporting it, we will ask you for a donation to the chapter. So then we create a better, let's say, foundation for the chapter activities and maybe to help the students in traveling to conventions. So I'm ready for more pictures if you are. Okay, let me go to the topic now. And in order to really, and I did it last year in Acapulco, I want to do it again here, really to pay respect to the places that I visit. I always have a translation of the English version of my presentation in the local language. I did it in Morocco a couple of months ago. I did it in Turkey. And I think is this not to help you? I know you speak English, okay? This is not the point, but is to tell you that I'm aware that I'm not in the United States. And so I think this is to recognize and provide the level of, I would say, respect of the people I'm talking to. So with this said enough, hopefully these couple of minutes don't count towards my presentation. I still have my, I think, 45 minutes. And then I'm asking Arturo, who is the guilty one for arranging all these trips, to wave at me when we are close to 40 minutes. So I'll stop and give you the time for some question. The new initiative of ACI, and then I want to go to the topic that is dear to my heart as a researcher. And I think that you will hopefully enjoy it and tell you what we're doing in ACI in terms of innovation. I think we are not a dormant society, just the opposite. So first of all, I want to remind you what is the vision of ACI. You can read it there, but the most important item is the last line, is this line here, is we want to meet the demands of a changing world, okay? We recognize that the world is not static. We recognize that we have new challenges. We recognize that climate change is there and is an opportunity for us to also change culture in our industry. So I don't look at the people with white hairs like myself, but I look at the young people. You are in a different business and you can get it from us, okay? Our role, the people with the white hair, is to help you getting there. ACI is a technical society. We are not a trade association. Even though I have lots of friends who are in the cement or concrete business, and actually I thank them for their support, we are not pushing concrete as a material system. We push knowledge. This is what makes us different, okay, from other groups. So be aware of the fact that we do not promote concrete. We are not a government agency. You are part of an organization that is all about generation and deployment of knowledge. So this is fundamental for me. And this is really what excites me. And maybe this is one of the reasons I was mentioning to the students, I've been attending conventions since 1985, and I only missed one. So I invite all of you at Boston. It's a great city. It's going to be during Halloween. It's not a bad place to be. And the weather is going to be a little colder than here, but maybe you can see the first flakes of snow there in case you have never seen one. It's a big institute. We have 18,000 members, 18,000 plus, without counting the members of the chapters. If you're a member of the chapter and not a member of the main organization, we don't count you as a number, but you are still there and you're a key representation of what we do as an institute. We also have 15,000 students as members, and membership is free, not because we're generous, but because we recognize the fact that the students are the future, not only of the institute, but of the entire industry that we represent here. Just to give an idea, we have just about 350 student chapters and more are coming. So we are very excited. The stakeholders of our organization are listed there. We have everybody that is part of our industry. And I think this is fundamental because in this way, we really represent all that are participants in our successes. We have more than 400 technical documents. I think the most important one is the code, and in particular, the building code. I was with Professor, well, I'm not going to mention the name, so otherwise people think that I do advertising here. But I was in UNAM a couple of hours ago, and I saw the new building code that is going to come out in the city, Mexico City. So I'm very excited. And well, it was mentioned to me that even though it's not identical to 318, one of the bases for that code is 318. So it's very exciting for me to say that this is perhaps our best contribution to the deployment of knowledge worldwide. We do many other things that you can see listed there. I'm not going to go into that. We believe in educational activities that are at the foundation of the deployment. So we do many things, but I also want to mention scholarships. And I want to entice the students who are in this room to apply for these scholarships. Okay, they are not just for students at the US institution, they are for everybody. And what we're trying to do next year, and I don't know if I'm going to be successful, but the idea is that you can apply, and if an essay is required, you can write the essay in your mother language, in your mother tongue, because we want you to be sure that you don't feel that you are handicapped because you have to do something in a language that is not yours. The next few slides are about the innovation, and I hope that this will get you excited. Probably, if you don't follow what we do at headquarters, this will provide a sense of innovation, novelty. ACI is an organization of primarily volunteers, right? We have a number of staff, 151 now. We have an office in Dubai. Okay, so we are a fairly robust organization with respect to the staff, but the backbone of the institute is the volunteers, is people like yourself, is yourself actually. So we tend to be reactive to innovation because you all have jobs, paying jobs, and you come to ACI just because you love it, because you want to make a difference, because you want to network, because you want to increase your level of knowledge, but you can only spend so many hours. So we have created centers of excellence that would allow us to be at the forefront of innovation. These centers of excellence are subsidiary of ACI, but they run independently from ACI. They have their own board of direction. They have their own executive director, their own technical director, and they are on themes that we believe, or industry believes, are at the forefront of what is happening today in our industry. The first one is this one called NEX, and is a center of excellence for non-metallic building materials. This is dear to my heart because I spend a lot of time in dealing with composites, but I think it goes beyond that. This is the newcomer in terms of the material systems that we use in our industry. It's concrete, steel, masonry, timber, maybe aluminum, and then the composite. And so the future has a place for these material systems. Why do we do it? Because these materials allow us to be more effective in the reduction of the carbon footprint. I'm not going to go into the details. You can read the slide, but one of the efforts that we make is exactly that, to be zero, if possible, by 2050, and these materials will help us towards that. We're also important for another aspect of the sustainability, which is the durability of our infrastructure. Maybe, I think you still have problems of corrosion in Mexico City, but if you go in areas of your country where you use de-icing salts, or where you're close to the sea, and you have the influence of the chlorides coming from the sea breezes, corrosion is an issue. Well, look at that number, 8.3 billion annually. That's in the US. And isn't this money wasted? Imagine what we could do with $8.3 billion if we did not have to repair structures. So this is one of the reasons why we think that there might be a room for materials that are different and that will allow us to maybe build with the service life of 120 years, which is our objective right now. So this center of excellence called NEX not only deals with composite rebars, that is what we call FRP reinforcement, that is my personal passion, but polymers in concrete. So the additives, the construction chemicals, the soil materials for soil amelioration, all the things that the non-metallic can do. So it's not just that. The other thing that I think could be exciting, if there is academicians in the room and students, through the center membership, we fund the research. Last year, we had 12 projects and we invested close to $600,000. This year, we are close to $750,000. And yesterday, there was an announcement, if you receive emails from ACI headquarters, that said that we open up a request for application, a request for proposals on 13 themes that are related to non-metallics. And everybody can contribute. Everybody, you don't have to be in a research unit. You can be in industry, you can be a contractor, you can be an engineer, and obviously you can be in academia. This is the list of the members. The two that I want to draw your attention to are Aramco and ExxonMobil. So why petrochemical industry? Okay, what are we going to do with all that oil by 2050, right? So if we don't use it for powering gasoline or cement plants, we might as well make resins, and resins that we can use, or additives or other things that we can use in other industry. The second one, in terms of age, it came after NEXT, is called NEW. And here the theme is what I think is really perhaps the most important issue that we are facing today as a society, not just as an industry, but we as people, we as consumers, is a center of excellence for carbon neutral concrete. Okay, so here are the efforts that we have. Are we doing research on this theme in this center? Not really. the major purpose of the Center of Excellence is not to conduct research like NEXT, but is to do validation and verification of the ideas that we as a community generate. So as an organization that is neutral, as an organization that is only interested in the development of knowledge, okay, we want to help society in adopting the right technology. So validation and verification are the most important items. The sponsors and the members of the center span across the stakeholders of our industry, from the owners down to the construction companies. And I want to bring your attention to the next slide. I've said this already a couple of times. Well, the young people in the room may recognize what Meta is. This is Facebook. Okay, can you explain this to me? Why is Facebook giving $500,000 to ACI in this center every year? Are they nuts? Are they, what is the reason for that? Is because they are building data centers, $3 billion worth of data centers in the United States alone. If they want to be net zero, if they want to do what they are preaching, how are they going to select the technologies? They need a neutral party that tells them, look, what this company is proposing to you makes sense. The other one, Breakthrough Energy. This is the foundation of Bill Gates. Why would Bill Gates give money to ACI? For the same reason. Because ACI can provide information, can assess the quality of a technology that has been proposed. So we have a very, very important role to play in society. The third and last center, actually we're working on a fourth one now on existing buildings, but this is already a reality. It deals with the productivity. We call the Center Pro. Why? Because one could argue that whereas other industries have increased significantly in productivity, unfortunately, the construction industry has not. We do many things like we did 50 years ago, maybe a century ago. And so it's about time that we readdress this issue and rethink it, and we look at best practices. So these are the core function. I think this center will look more than anything else to the construction companies as members, but certainly also engineers, okay? So remember, productivity is not only when you are in the field, is also how the designers design. And you can design so that it's better, is easier to construct. You look at the constructability, you don't look just at the optimization of your work. This is a pitch to remind you that we hope to see as many of you as possible at convention in Boston. And if you cannot make it in October, at the end of October, hopefully we will see you in March in New Orleans. Conventions, for the ones who have been there, I think they are great opportunities. And I hope that at least the leadership of the chapter will be with us in Boston at the end of October. And now I want to kind of switch gear. Maybe we can pause for the question later. And I want to tell you a little bit about this document that came out September the 2nd of last year. So it's not even a year old. And I think this is very exciting because if some of you were in Acapulco almost a year ago, can remember that I was already talking about FRP, but we did not have a code. And actually, I'll tell you even more. The 2 weeks after ACI published this document, after a major effort, ICC, the International Code Council, decided to adopt it in IBC, the International Building Code, the Model Code. So this means that this document will be part of the law of the land in the United States because the 50 states use the IBC as the model code. So in any country that is using the model code, this is also the law of the land starting next year. So why do we do this? I mean, kind of obvious, like I already mentioned it. We have used many ways to slow down the issue of degradation of reinforced concrete. We have looked at additives. We look at additional cover. We put membrane. We have coated the steel, but corrosion unfortunately happens, right? It happens because we have the chlorides entering the concrete. It happens because we have carbonation of the concrete and all these reasons, okay? So now we say, well, look, why don't we use these FRPs, fiber reinforced polymers, to perhaps give us a solution? Is going to be another tool in the toolbox. So today we are using primarily, at least this code speaks to material systems that are made of ECR glass fibers. So these are corrosion resistant electric glass type. We're using a thermoset that is a vinyl ester, but the new ASTM will also open up to other material systems. But today, the 440.1122, the code that we have issued last year, refers to a material specification that is D7957. So now we are blessed by the fact that we have a material spec, we have a code, and also we have another document that is 440.5 that is construction specification, material design code, construction specs. We have closed the circle. The bars kind of look different from the one that you are familiar with. They all, depending on the supplier, they look different because these manufacturers have not standardized the surface configuration, but all these bars, if they are compliant with the ASTM D7957, provide adequate bond. In order to make sure that these elements are consistent or are compliant with the code, we run a series of different tests, and I list some of them. Some of them may not be familiar with civil engineers, like enthalpy of polymerization. What does that mean? Well, in very simple word is if you're baking a cake, you want to make sure that it's cooked. And this is the enthalpy of polymerization. Because if the polymer is not fully polymerized, then it will absorb water and you will lose the durability that otherwise you would have with the proper cure. This ASTM D7957 prescribes many things, including the size of the bars. So not only the strength, not only the constituents, but also the dimension of the bars. And here I could spend the afternoon telling you why, but I'll skip it because today I'm emphasizing the good part of FRP. And maybe you will ask some questions about the challenges. It's a material that is high tensile strength, but less stiff than steel. So the stiffness is, let me just use a number so we're there. If you think of steel, now think of FRP giving you a stiffness that is a quarter of that. The implications are significant in terms of serviceability, but we can live with that. In terms of strength, if you take a grade 420 MPa steel, the bread and butter of our industry, we have a strength that could be easily 2.5 times that, but the stiffness is less. It's a material that is anisotropic, properties in two direction are different, and there's a material that, this is a very important property, is elastic to failure, is elastic to failure. And so these are as implications, I will show it in a second, if you go into seismic design, that is obviously of significance. The strength of the bends is less. This is perhaps one of the weakest points. The compressive behavior is also less than the tensile, and the shear behavior is different than you are used to with steel. And then under sustained load and cyclic load, we have a phenomenon that is called creep rupture. What is the point that I'm trying to make? The point is nothing is perfect, but as engineers, we can design and we know what these properties mean to us. The other thing that we have done over the years, because there was a question about durability, we have run tests on samples that came from bridges that had been in place for at least 15 years. And we have demonstrated that there is really no degradation of the GFRP bars, even though in those days the fibers were E-type, not ECR, and in many cases they did not use a vinyl ester, they use a polyester, which we no longer use. So this is the code. It's a great document. I hope that you will eventually put your hands on it. It's relevant because it will open up a new set of opportunities for both the designers and the contractors. As a code, obviously the objective is, primary objective is minimum requirements to guarantee safety. Okay, this is the objective of every code. And as I mentioned before, it is related to bars that conform to the requirements of D7957. So compliance with the material spec is a requirement. If there are bars that are maybe deployed in this country, Mexico, you need and you like to use them, ask the supplier if there is compliance with ASTM D7957. If not, you should not use them. The material is linear elastic to failure. So when I was with Professor Alcocer this afternoon at UNAM, I said, you know, this seems to be a problem, but it's not really a problem. Not always ductility is what we really need. And there is a movement that the ductility that results in very high level of damage in a structure after a seismic event present dramatic challenges for repair rehabilitation. So designing with materials that are linear elastic could open up a new world of opportunities for us. But as of today, we recommend to use this only in seismic zone A, that of the 4 seismic zone, A to D is the one with the low level of seismicity. The code covers as the same structure of 318 for the ones of you are familiar with it, but skip some chapters. I'm only going to mention 2. Diaphragms. We don't have enough knowledge about diaphragms. There has been not sufficient research on it. So we say, well, look, the code is silent on it. It will say not applicable. And other chapters come plain concrete. Plain concrete is covered in 318. Why do we have to rewrite it? So this is not a limitation, but is something that you need to be aware of. And then I want to stay on this issue of ductility, but we are now thinking in terms of deformability. So give you the same premonition to failure with deformation rather than plasticity. And we have calibrated the safety factors, the phi factors, the strength reduction factor to give us the same reliability that we have with conventional structures. So I'm not going to go into details here. This is more for the designers, but I just want to make sure that you understand the fact that even though the materials are elastic, linear elastic to failure, the safety remains the same, if not higher, than in the case of traditional structures. I mentioned differences. When you design with FRP, you need to be aware of some of the peculiarities of the system, and in particular, look at items like the shear strength, the dowel action, and bond performance. And then because of this issue of stiffness being less than in the case of steel, sometimes the serviceability in terms of either deflection or crack width could be an issue. The last item, in order to be accepted by ICC as being part of the International Building Code, we became silent in this version of 440 to the issue of fire resistant ratings. And the reason is because we did not have enough tests conducted according to ASTM E119 to present to the building official. This type of work is going on right now, and I'll guarantee you, and maybe I'll mention it, in some instances, the performance of a GFRP RC structure is better than the one with steel RC. Why? Because at the temperature of 400 C, the stiffness of steel is gone, right? The E of steel, the module of elasticity, goes to zero or decreases significantly. If you have a structure reinforced with GFRP, what happens at 400C? You melt, or you really degrade totally the resin, but the fibers are not degraded. So if you have continuity in your structure, if you have continuity in the reinforcement, if you anchor the reinforcement, you remain intact. So we're doing some work in tunneling that is really amazing in terms of safety under fire. So this is not a challenge. I see this as an opportunity. The only thing I also want to show is that we are so conservative now that we even apply a reduction factor, what we call C sub B, to the value of the guaranteed strength that comes from the supplier. By the way, that guaranteed strength is the average minus 3 sigmas. Let me repeat it, the average minus 3 sigmas. And to that, we also apply this C sub B factors that in the case of the new code, we move it from 0.7 to 0.85. The fee factors, and that's the last one on the technical side, we go from the conventional zero in flexure, let's mention. In shear is the same, but in flexure, we go from 0.9, we go down to 0.65 and 0.55, also because we allow the failure in compression. And so, which is, unheard of in the case of flexural elements. Obviously, we allow failure in compression in columns, and that's why the fee factor in that case is 0.65, and it degrades to 0.55 if you have a failure in the FRP itself. So in columns, we're even more conservative. We disregard the stiffness of the rebars and we replace them with an equivalent area of concrete. And again, we also limit the tensile strain because we want to maintain the deformability to levels that are acceptable. I don't know if I show you this last time, but this building is under permitting in Miami. It's certainly not iconic. I know that we are in the home of architects, so I'm not going to take any credit on the design. I did not design it in terms of architecture, but this building that is under permit is a 3-story building, does not have a single pound of steel in it, and will be built hopefully starting the fall. I just want to give you a sense of some applications. These are hopefully, this is the last part of 3. These are for real. This is stuff that I've personally been involved. I'm going to use the term we, but it's royal we. In some instances, I did not really have a very significant contribution, but certainly I work on these items. Where is the use of FRP? Obviously, I mentioned it before. The obvious one is this one, concrete structures susceptible to corrosion. You probably don't do many of these, but they do exist. If you want to have electromagnetic transparency, this is a material system that you can certainly use. I'm not going to mention it later, but for example, in the precast industry, there is no conductivity in FRP. So you can cut down the size of the cover and only have the cover that is necessary from bond. So you can go to from 39 millimeters, maybe to 20 millimeters cover. In a panel that is maybe 150 millimeters wide, if you can shave 25 millimeters, do you know what this means in cost of savings? I'm sure that, or I look at the dark looks from the cement manufacturers that I think they are going to sell less. No, they are going to sell more because we can make more panels. And then we increase the radius of transportation. It's all about weight. And the FRP, by the way, is 1/4 the weight of steel. Do you know what this means in terms of transportation of rebars? Do you know what this means in terms of the back of the workers? The union, the workers' unions in New York City loves this. Why? Because people will get less injuries over time. So again, these are benefits that we engineers can, or academicians in particular, don't really consider, but they do exist. The other application is now 100% in the world. I don't know, I'm sure that you do some tunneling work in Mexico. When the TBM, the tunnel boring machine, enters the wall, the wall that, allows the, let's say, the confinement of the soil and needs to do the cutting, what we call the soft tie. If you were to have steel bars, you will ruin the sharpness of the cutters. So the fact that you have FRP and you can machine it has become now a common thing worldwide, including, for example, I think the best example that I had some participation is in the channel that connects France to England. The FRP was used there in the soft ties. So I'm going to give you two of the many presentations that I have, and if you're interested, I will leave the slides set with the chapter. They can send you a copy. All the others have been hidden, so I'm not going to present them here, but they are available if you create a PDF. So the first one is a little, almost insignificant structure that we built in Miami after a hurricane, because the owner wanted a structure that would last 100 years and resist Cat 5 hurricanes. Now, this is all precast concrete. And guess what? It was cast using seawater. Okay, we wanted to make a statement. This is kind of crazy. Why do you want to do this? We have still plenty fresh water in Miami, but we wanted to make a statement that this type of approach does not need fresh water. The chlorides do not affect the reinforcement. So imagine what this means for you as an industry. You can go back to the calcium chlorides as accelerators. They cost less, they are very effective, but we have banned the use of them because of the chlorides. So now opens up another world. You can use recycled concrete that is chloride contaminated. If you demolish a bridge, you can use the rubble to make recycled aggregate. And you don't care if it's chloride contaminated. So all this is in the perspective of sustainability. So these are the units being cast at Course Lab in Miami. And this, again, I don't want to get into details, but all the elements were precast and then assembled at the site. The exciting part is that the piles were RC, not PC. These are very small piles, but they are the common and most normal in coastal construction in Miami, maybe 8 feet long, square, 25 centimeters. And so the installation was with conventional equipment and very successful. In this case, in addition to the glass FRP, we use the basalt one, which is interesting. And I know some distribution may happen also in Mexico. So these are the pictures of the of the pier, almost with construction completed. And the owner was so excited that 2 months ago, he just sold the house. You want to know the amount? $15 million. And I think that maybe part of it is because this great pier. No, I don't think that's the case. But we went back to the owner and said, could you give us a little donation since now you have sold the house, but with not much luck. The next project is on the other side of the Atlantic Ocean, and actually you go on the other side of Africa. We go to a flood mitigation canal in a new city that's being built in Saudi Arabia, in Jazan. And the reason I want to bring this up to you is because used to be, it is now the second largest project in the world in terms of the use of materials, but speaks to applications that don't need to be buildings, or they don't need to be bridges, they don't need to be piers, but is an area of great interest even now in the United States in what we call the pre-engineered application, such as slabs on ground, walls, retaining walls for residential construction and so on, where you design without an engineering seal, but you design by using tables. So this is the city. This is in terms of geography, the city of Jazan, as you can see, is on the Red Sea and is being built, really to provide refineries and to give Aramco an access to the Red Sea and potentially move goods both to Europe through the Suez Canal and to the United States across Africa. And they needed this flood control canal to protect the city along these two sides. Believe it or not, it rains there every once in a while, and when it rains, it pours. But it was interesting. The biggest challenge that we had during construction had nothing to do with the rain. It was the sand. And when you get a sandstorm, you have to go back and clean up the area. And boy, this is very interesting. So anyhow, this is the cross-section of the canal. It's 20 kilometers long, 40 meters wide, and it was originally designed with epoxy-coated steel. And then Aramco, that is the client, came up with this brilliant idea. Hopefully we had something to do with that, to say, well, look, ask EECOM to redesign it using GFRP rebars. And eventually, together with the contractor, a company called Yaman, they decided to go with the option of the GFRP. And here you see some slides of the construction, very significant, not the prettiest landscape, but certainly a very significant construction. You can see here the amount of material. I want to mention this to you. How many cranes do you see at this site? Zip. And the bars were old pieces that were 40 foot long. Okay, so very significant. So no cost in terms of cranes. So here you see some of the construction during the day, but most of the construction was done at night due to the temperatures. The last slide on this project is numbers. I know if there is some contractor, and I know there will be questions related to this later. Look at this number. What is the meaning of 79? Is 79%. That means that there was a 21% savings on a first cost basis. Okay, let me repeat this. Not only now the owner believes, and we believe with the owner, that the life of that structure will be 100+ years, but they save 21% of their dollars. And so this is a significant amount. The point is very important here. If you have a first cost of a new structure, of a new technology that is higher than the first cost of the traditional, I think you are going to have a very hard time selling it. But not because people are stupid, because if I need 2 bridges, and with the amount of money that I would do 2 bridges with conventional, you can only build 1. Would you accept it as a public? If I need 2 bridges, I have to have 2 bridges, not 1. So first cost is fundamental. And now we are in a situation where the cost of these materials is certainly lower than epoxy coated. And there was a moment in time during this past year that was much cheaper than steel, black steel, because the fluctuation of the price of steel. So some conclusion very quickly. I think I ran out of time, but I think I made the point that we have a compelling reasons to believe that we are looking at a sustainable material, and the sustainability comes from the fact, the major fact is that is a technology that is less dependent on us for providing new material, the natural materials, the fresh water, the natural aggregate, or the mine aggregate for that matter. So very, very interesting from that perspective, even if it is a projection towards the future. It eliminates corrosion, so it reduces maintenance cost by obviously big time, increases the service life of the concrete structures, and improve the constructability because of the smaller or less weight compared to steel. And with this, I thank you for your attention. And if there is time, I'll be delighted to take questions. Gracias.
Si alguien tiene una pregunta, por favor, levante la mano. Grazie, Mr. Nani. Iniziamo con la sessione di domande e risposte. Acá.
And they can be in Spanish too, if you speak slowly, it's okay.
Sí, buenas tardes.
Buenas.
Yo quiero preguntarle algo. En la Ciudad de México es muy común usar en la cimentación por el tipo de suelo que era la Ciudad de México un lago. Usamos pilas o pilotes por la cuestión sísmica y para llegar al extracto más duro dentro de lo que es la Ciudad de México, a veces hasta 32 metros y quizá más, ¿no? Yo quisiera saber si este tipo de barras es posible usar para pilas y pilotes y si esto, bueno, por los tipos de suelo que tenemos, hay mucha sulfatos por las áreas, muy parecido a donde están ustedes y lo que yo recuerdo en esa región de Michigan, muchos lagos, el nivel freático muy parecido a las arcillas de la Ciudad de México y que se nos inundaban los Bainman cada vez que había que sacar el agua y otra vez vuelve a inyectar y bueno, terrible aquel tiempo, ¿no? Ahora, pues creo que también su infraestructura de ustedes tiene muchos problemas en los puentes con la corrosión, la carbonatación, la sal y más cuando llega el invierno 4 meses, era terrible, o sea, yo lo recuerdo y eso me trae recuerdos nada agradables, pero bueno, el escenario es algo muy parecido, si es posible aplicarlo en pilas o pilotes.
You pose a difficult question, and I should pretend I did not understand it because it's in Spanish. No, I did understand it very well. So let me break it down into two parts. There is no doubt that you can use these materials in piles, and the length doesn't matter. And actually, the durability is going to be related more to the performance of the concrete than the performance of the reinforcement. So on the durability issue, on the length of the pile, on the size of the piles, it doesn't matter. You ask a difficult question if you were to say, I want to do it in Mexico City, where I have seismic issues. But then I'm going to reverse the question to you, and I'm going to say, this is a personal opinion. I don't represent ACI here. I think, in my mind, it would not make much sense to have the piles being the elements resisting lateral roads. And the reason to me is simply the following. If they were to be damaged, how are you going to fix the piles? So I think that the best way is to have the elements that resist seismic loads be off the ground and potentially be elements that can be replaced. We are looking at a situation again in Saudi Arabia for NEOM, where they are building that incredible project called The Line, where they have the same issues. And I think my personal position is move away the problem related to lateral loads from the foundation and put it in the superstructure. Because if you ever have a seismic event and you have to go back and fix it, how are you going to do it? Because again, it is a sustainability issue. So again, there might be others that totally disagree. That's perfectly okay. And but I think that this is the trend that I see. And or other possibilities are, you know, if you are building a high-rise building and you have a basement, the stiffness that you are required to have for lateral loads could be in the basement. But I think even more importantly, I think the idea either of seismic isolation or sacrificial elements should be the driver of design. Again, personal opinion, don't take it as a statement from ACI, because I know that quite a number of people could disagree, but excellent question. My pleasure. Any other?
Primero que nada, buenas tardes.
Sí, se puede oír.
Omitiendo la parte de tal vez hablar de un sismo que recomiendan no usarlas, pensando en cargas cíclicas, tal vez bueno, ya partiendo de una zona no sísmica, tal vez la la costa este de Estados Unidos. Una carga cíclica, como por ejemplo un estadio, un lugar como que va a estar gente saltando, por ejemplo, tal vez algún edificio que esté destinado a uso recreacional, ¿sería recomendable el uso realmente o seguir con lo convencional de secciones de acero puras o secciones compuestas entre concreto y acero?
Great question. Actually, not only in buildings and stadium and other structure, but think of a bridge where you have cyclic load that are really the reason of the bridge. The way that we design for either cyclic fatigue or static fatigue is the same. We limit the stresses at service in the case of GFRP to a value that is 40% of ultimate. And the reason is because we know for sure that if you were to have either cyclic load or static load exceeding 40% of ultimate, you will eventually experience failure. So the answer to your question is cyclic or static fatigue is not an issue because we know how to design. And actually, the best applications are, as of today, in bridges. And you could say, why in bridges? Well, because we can identify the owner. You see, in building, okay, I hope that there are no developers here. But in buildings, you have a situation where the developer typically does not care about the durability of a structure. A developer cares about building fast and selling fast, right? The position of a public official that is responsible for a bridge should be different, is different. That person needs to guarantee the public that the structure will have a long life. So when we go to the bridge owners, we need to be sure that what we are proposing is a solution that is not going to last a very short time. But actually, I did not show bridges today, but we have designed, for example, 2 bridges in Florida that are 100% FRP from the foundation to the superstructure. If you go down to North Carolina, there is under construction probably the longest of the bridges that is using 100% of FRP. These are not demonstration projects. These are projects that the Department of Transportation has selected to be with these materials. The piles are pre-stressed concrete with carbon FRP because it's more efficient, because you can reach the same level of stress that you have in conventional low relaxation steel strands. But the rest of the superstructure is all GFRP. So again, you're absolutely right. You need to know what you're doing in design. You cannot overdo it. But and that's another reason we use carbon FRP in pre-stressed concrete is because the issue of creep rupture, static or cyclic fatigue is not existent. So glass obviously is much cheaper. We would like to use it whenever we can. Well, actually, for example, we have done some piles, also pre-stressed concrete using glass, but we stress them at 30%, 35% actually to be correct in terms of their ultimate. And we do what we call mild pre-stressing, which economically could be very advantageous also because it's much easier to pull the tendons. By the way, in that case, the low modulus is a blessing. The precaster loves it because when we pull a GFRP tendon at 30% or 35% of ultimate is the same elongation of the steel strands. So they don't measure the force, they measure the displacement of the head. And so it's very, I could talk about this issue for long, but maybe there is room for another question. A difficult question. These are the easy ones. No, I'm just kidding. Other questions? If not, we. Okay, so it's a promise that I'll come back next year. Mexico City, I would like to see an application, right? You will have a code that allows you, I understand it's going to come out in September. You know, take leadership. By the way, I have to admit, not because there are cement manufacturers in the room, but I attend meetings of an organization called FICEM that represents the producers of cement and concrete in Latin America. Wisely enough, They meet 3 times a year, their board in Coral Gables, Florida, because Miami is a capital of Latin America, right? So, well, I don't know why they come to Florida, but I love the idea. And I have to admit that these companies are more progressive than the US, twins. I mean, because they operate on the entire market. But the commitment to sustainability that you experience here is really amazing. And I congratulate you for that. And we wish to see more. So work on the chapter would be the chapter of professional members, but also the student chapter. We hope that support will come, and we're going to see you in Boston coming October. By the way, it's going to be Halloween. Halloween in Boston is spectacular, so don't miss it. There could be another reason to be there that has nothing to do with concrete. Thanks for your time. Deeply appreciated. It's been an honor to be here with you.
Grazie, Mr. Mann. Per favore, continua con me per continuare con el programa. Grazie. Con esto finalizamos el espacio de preguntas y respuestas. Le pido por favor a los integrantes del Presidium nos acompañen nuevamente para dar inicio con la entrega de banderines de excelencia a algunos capítulos estudiantiles. Pero antes de eso, quisiera pedirle al ingeniero José Alfredo Rodríguez nos ayude por favor a hacer entrega de un reconocimiento a nuestro orador, el señor Antonio Nani. Un reconocimiento para nuestro orador. Un fuerte aplauso, por favor. Muy bien. Y ahora sí vamos a continuar con la entrega de unos banderines de excelencia a algunos capítulos estudiantiles. Les pido por favor a los integrantes del Presidium nos ayuden a hacer entrega de estos banderines. Reciben las siguientes universidades destacadas. Marco Antonio Cerrato Contreras, presidente del capítulo en representación del Instituto Tecnológico de Iztapalapa 3. Un fuerte aplauso, por favor. Muy bien, nos regalan una fotografía, por favor. Cámara 1, cámara 2, ¿listos? Un fuerte aplauso. E igualmente le pedimos a Liliana Román, presidenta del capítulo en representación de la Universidad Autónoma del Estado de México. Fotografía, por favor. Muy bien, demos un fuerte aplauso, por favor, a todos los galardonados. Y ahora daremos inicio con la toma de protesta simbólica de la 26ª mesa directiva de la American Concrete Institute, sección Centro y Sur de México para el periodo 2023-2025. Voy a invitar a los miembros de la 26ª mesa directiva y los voy a mencionar. Les pido por favor se pongan frente a Mr. Antonio Nani para poder hacer la toma de protesta. El cargo de presidente lo asumirá el ingeniero José Alfredo Rodríguez Campos. Un fuerte aplauso y les pedimos por favor ponerse de frente. Les pedimos irse poniendo de frente a Mr. Nani para poder tomar protesta simbólica. Gracias. El cargo de vicepresidente lo asume el maestro en ingeniería Sergio Valdés Constantino. La dirección financiera la asume la arquitecta Concepción Jiménez Medina. La Consejería de Certificación la asume el ingeniero José Gustavo Montoya Aguilar. La dirección de planeación y difusión la asume el ingeniero Julio César Medina Chávez. La dirección técnica 2 la asume la ingeniera Carla Elizabeth de la Fuente Monforte. Y la dirección de capítulos estudiantiles la asume el ingeniero Guillermo Guerrero Hernández. Muy bien. Ahora sí solicitamos a Antonio Nani, presidente del American Concrete Institute, realice la toma de protesta simbólica a la 26ª mesa directiva para el periodo 2023-2025.
Distinguidos miembros de la 26ª mesa directiva, protestan cumplir y hacer cumplir los estatutos generales que rigen las directrices de funcionamiento de la sección Centro y Sur de México del American Concrete Institute. Si así lo hicieron, que la comunidad del ACI se los reconozca y si no, que los demande. Fantástico. Congratulations. Felicitaciones, felicitaciones, fantástico. Felicitaciones, felicitaciones.
Muchísimas felicidades. Es así como concluye este evento. Muchísimas gracias, señor Antonio Nani. Invitamos a todos los asistentes a colocarse cerca de esta mesa para poder tomar una fotografía panorámica y posteriormente los invitamos al jardín para disfrutar del vino de honor que tenemos preparado para ustedes. Muchas gracias.
This was a surprise. You should have told me. I had no idea. Okay. I should have. No.